Hello, and welcome to a fascinating presentation on student engagement, motivation, and success in Calculus 1, Is Gaming the Secret with Rob Eby. My name is Amber Munzenberger, and I'm the Director of Learning for Triceum. Today, we are excited to share Rob's classroom experiences using gaming to inspire and motivate his students. We have a few poll questions to help us get to know you better. First, how would you best describe your institution or university? While you're answering this poll question, I have a few housekeeping tips to make sure you have a smooth experience during the webinar. If you have any technical difficulties, first, try clicking on the Reconnect button on the bottom of your screen. If this does not work, please use the chat box to send us a message and we will try to assist you. During the webinar, please feel free to type any questions you have for Rob in the chat box as we go. We will answer questions throughout the webinar and at the end of the presentation. Lastly, we hope that everyone will follow us on Facebook and Twitter by searching @Triceum and use the following hashtags: GBL, Game to Learn, and Gaming. Before I introduce Rob, we have one more poll question. What type of course do you currently teach? Now, it is my pleasure to introduce Mr. Rob Eby. Rob has been teaching math at Blaine College in Bryan, Texas, for over 13 years, with special interests in educational pedagogy and innovations. Mr. Eby works with new technology in the classroom that enhances the learning experience for his students. Rob is a longtime member of the American Mathematical Association for two-year colleges, AMATIC, the Mathematical Association of America, MAA, the National Council for Teachers of Mathematics, NCTM. He is a respected speaker that has presented numerous times at ICTCM, the AMATIC National Meeting, and the Joint Mathematical Meetings. He is also a member of Cohort 2 with Project Access, AMATIC. We are very honored to have Rob Eby with us today to share with this webinar. With that, I'll turn it over to you, Rob.
Okay, Amber, thanks. So it's kind of funny. We actually, even though Triceum's headquarters is like 2 miles from Blaine's campus, we ended up not really kind of knowing about each other until we met at a conference. It's funny how things work like that. But I was really excited about this idea of using video games to try to learn calculus concepts. One, I love playing video games, but then two, they have sort of the feel that we want our students to be engaged with. So if you ever watch people play video games, they'll tend to bang their head against one problem for 20 or 30 times and keep working at it and trying to do it, sort of a thing. But with the homework, right, at least in my experience with the students, they'll do the problem one time, maybe 2 times, and then I give up, this is dumb, move on. And then if your calculus classes are like mine, you probably have a fair number of students, about half your class, who's had calculus in some form or fashion before. They just want to race on. And when are we going to get to derivative rules? When are we going to get derivative rules? Why do we have to do all this stuff? Well, we know that limits really in the concepts there are foundational, not only for derivatives and understanding what's going on, but when you start talking about Riemann sums toward the end of class, the idea of a limiting of the sum and this sort of a thing. And I was also really excited because Triceum is actually run by a real video game design group. It's growing up in the 80s when I played games, you kind of wander around a dungeon and then, oh, there's the magic door and you must unlock the door by solving the equations. Like, yeah, but this is really an immersive sort of game. And to give you an idea for that, we'll play the trailer here in just a minute to give you a couple, 2-3 minutes. You won't have to do anything. It'll just auto play, give you a feel for what goes on in the game sort of thing. And then I'll pick up back after that to talk more about how I use the game in the classroom and stuff like that.
From engineering to medicine to 3D graphics, calculus is foundational for all STEM careers. However, calculus courses today have among the highest failure rates of any course on any campus. And there is a growing body of evidence that explicitly ties calculus to attrition in STEM degrees. At Triceum, our team collaborates with educators to address these complex educational issues and transform how students learn. Welcome to Variant Limits, the first in a new series of immersive educational experiences for calculus students. Variant Limits brings calculus to life by transforming abstract ideas into creative and visually engaging challenges. As an explorer on a planet governed by calculus principles, students will discover a vibrant 3D world. Throughout the world, students will overcome obstacles by applying skills and concepts learned in class. Students will gain a new perspective on difficult topics such as limit laws, continuity, and the intermediate value theorem, and use their experiences within the game to construct and retain calculus knowledge. Variant Limits promotes conceptual understanding through direct interaction and immediate feedback in the game environment. By providing students an opportunity to take a more active role in the learning process, Variant engages and motivates students like no other learning tool. As students advance, learning is reported via the Instructor portal, which provides detailed information and tracking tools. A revolutionary new way to teach calculus, an innovative tool to empower and engage students. The first in a series that will transform the calculus experience. Play to learn with Variant Limits.
So how do I use Variant in the classroom? There's a couple of ways that I do this. As I mentioned before, right, even with the online homework that I use and other things, students quickly tend to get frustrated with the standard types of problems. They give up, they want to move on, and the usual, this is boring stuff. But if you drop them in a video game and suddenly all that almost disappears and they're immersed in the game, and as you could get a hint of from the trailer, it's an immersive game. It has a soundtrack, has a backstory, has a whole bunch of puzzles that all connect to each other about why you want to solve these particular puzzles and so forth. And so the students get immersed in this, and then it's sort of at their own pace too. I mean, I can set time frames of when they have to be finished, but they can play the game fitting around their schedule. And so we get some of that active self-regulated learning going on. And then I have the instructors portal where I can monitor how they're going. Then one of the other things I like about that is you could get a hint from the screenshots of the game. It's not a traditional limit question, so they're having to conceptually think of limits in a slightly different way and then make those connections. And we all know the more times they can think of limits in a different context, it deepens those connections. So I want to talk a little bit about some of these and show, and then here in 5 to 10 minutes, show an example of how I use this in the classroom, right? So for instance, here you can see there's a particular, they have to move the slider down here to pick the particular point that makes the puzzle complete, so that then in the game world, they're able to make the connections and move on. So here you can see a shot of the instructor portal, and it tells me not only for each student where they are, how they've progressed in the game, how long they've spent in the game. And so if they're stuck on a particular puzzle and they come up and say, hey, I'm stuck on a puzzle in the game, I don't have to get them to try to describe the puzzle or pull up the game. I can just pull this up real quick. Oh, that puzzle, go to a particular set of all the puzzles that I have and go, okay, well, let's talk about this one here particularly. What's going on? How does this connect to other stuff? Sort of a thing with that. So there's 4 zones or areas in the game. The first is the basic idea of, okay, what is a limit from the left, from the right? What's a function value at a point? And then that starts to tie into the idea of continuity for a function. What exactly do we mean when we talk about a function is continuous? Why is that important? As you can see from the different screenshots, they have to basically, the student or the player fills in the various circular orbs to match up what's happening at the particular point conceptually. Zone 2 extends that to functions. So for instance, here we have a couple of different functions, and in the orange box here, you can change to either function value or limit from the left or right or the actual limit. And they have to deal with both of these to make, in this case, the 2 circular doors line up to allow a path through. Here, what's going on is they actually get more operations depending on other things that they're doing sort of behind that to be able to unlock the particular puzzle in the game. So they're having it's a non-routine sort of way of approaching limits, and the students having to think about, okay, wait, do I really want to multiply these two functions? Do I want the division to go on, as opposed to the more straightforward, okay, here's F, here's G, multiplying together, what's the limit sort of a thing. Now, zone 3 comes back and ties in the continuity to all this limit stuff. What is actually going on? Why is it important to have continuity? And then in a later stage in the game, they actually have to create all the different orbs that they need, little circular things. So at first they're given the right number. Here then they have to actually come up with, okay, how many do I need? What's going on at these particular places? And then as it says, how does this tie into the intermediate value theorem, right? And again, these are all sort of non-standard ways outside the typical classroom questions. So it challenges students to nail down the concepts of what's going on. And then finally, the fourth zone is asymptotes, more particularly asymptotes at infinity, right? So what happens is X goes really big, really small, and then at a particular, usually vertical asymptote, what's happening when we say the limit from the left is infinity? What does that really mean? What does that look like? How does that tie into the notational side of things? And then, so example here of how I use this in classroom. So one of the ways that I do this is I take a screenshot from textbook. This one's taken from Stewart Calculus, but there's several, of course, similar ones in every calculus textbook. And so I take the snippet example from the textbook, the snippet of the example from the game, and I say, okay, where do these have commonality? So for instance, here in example 1A, it asked us to find f plus 5 times g as x goes to -2. So why is that a problem? What's the particular headache here? And then, okay, down here in the game, what's point or value matches that in the example? And you progress through the rest of them. And so here, I'm forcing the students to, one, tie the game on their own back to what we've done in class, but also then forcing them to reconcile all the different ways that this has been presented to them so that the connections are sort of nailed down. One of the really nice things, this was kind of a surprising thing to me at first when talking with the students, was it the way the game nailed down their conceptual understanding of a limit not existing. So here they're moving around the slider and it's moving a couple of walls to be able to solve the puzzle. And at one point when you get to a limit, the limit does not exist and the wall literally disappears. And it was kind of one of those aha moments for a lot of the students that you could hear them sort of gasping and say, yeah, man, when I saw that wall disappear, suddenly stuck. Oh, this is what it means for a limit to not exist. And in talking with the student, they said, yeah, I could, okay, sure, it's just not coming in, so limit left not equal, but mechanically I could do that, but it really didn't sink in just what exactly is the big deal about this till suddenly the wall disappears and it hit me that, oh, there really is something important about this. There really is something going on here. So that was a nice thing to happen sort of in the generated a rich discussion in class, actually for 15 minutes or so with other students about, oh yeah, hey, I hadn't gotten to that point yet. How do you get there? Or, oh, I was stuck on this point. So they're talking back and forth to each other about, well, no, remember this goes in, and then one of them popped up on their own, one of the students, and said, oh wait, didn't we do a quiz question like that? And they're digging back through their quizzes for all this stuff. And here they're talking calculus limits when beforehand they were telling me how boring it was. This was a really nice sort of a thing to motivate the students. And again, when we have these discussions like sine 1 over x, and the function wiggles or oscillates too much, and it's not damped oscillation, that, okay, the limit's not existing here. It's a different not existing in that sense than it is for an asymptotic behavior. And as you can see, the game also deals with that in particular instances. And here they've actually rigged the graph so that, okay, it does have a limit from the right, but not from the left. And that's different for students. They have to wrestle with, okay, why is it this particular way? And again, I come back to what's going on here in classroom examples, come up with some exemplar functions of this, and okay, how does this match up? All right, so I mentioned using this in class. So how do I do this? I want to talk about one. We have time to really talk about one here with this, but a couple of ideas of how I use this in class, other than just go out and go play this. One, I talked about, I compare the game puzzles to homework questions or quiz questions from class. I also sort of flip this around. I take a screenshot from a puzzle and I give it to each student or a group of students, say, okay, come up with a couple of quiz questions that would relate or use this game puzzle in a classroom setting. And some of them try to cop out, but it's interesting that sort of the competitive nature takes over for a lot of them. And they come in and they start trying to sort of outdo each other with, oh, wait, let's make this a question because I got this, but I struggle with this. So let me figure out how to do this here. And then one of the other things I do is, okay, so I take the quiz. So the two white pieces are I clipped from a quiz that I give in class, sort of standard quiz on limits. And then I took a screenshot from the game, one of the game puzzles, and I asked the students, okay, so for the puzzle, which of these parts over here do these puzzle questions correspond to? Which is it not to? And students are always talking about, well, there's not limits. This one has asymptotes and all that stuff. Yeah, I know. So why would it not correspond? And so that gets the discussion going about, oh, okay, this function in the game doesn't have any asymptotes. It only has its step discontinuity or jump discontinuity. But this question you had on the quiz actually has asymptotic behavior going on there too. And so you get the students to sort of on their own distinguish the difference between the different types of problems with a function, the discontinuity of a function, what's going on with the different limits with that. Okay, so the student impact. I have a little bit of anecdotal evidence that the students liked it and it had impact on the grade. I say anecdotal. I used it this past spring as sort of a review heading in towards the final in a applied calculus or business calculus sort of class, just the timing of things and when it came around. And anecdotally, the sample size though was only about 12, so I really wouldn't want to claim any great research on this. But if you contact Amber afterwards and she'll post her email and stuff, Tricem is doing some bigger research in efficacy studies with large student populations and pre and post testing and that sort of a thing. In fact, I helped them write some questions for the pre and post test on that. But anecdotally, my students did better, I would say significantly, but again. And then also just as they said, hey, this actually kind of motivated me to look back over this stuff as opposed to sort of just glance at a couple of examples. And I was going to have a couple of so-called engineering calculus classes this fall, and I was actually going to use it at the start to tie in, but then Glen is 90 miles northwest of downtown Houston. And so, yes, when Harvey hit Houston, it was dumping 24 inches of rain in 3 days on us. And we actually had to close school for a couple of days. And as you can imagine, losing a classroom day in calculus, I kind of punted and decided that maybe also introducing a game I just didn't have the time to do. But I am working to have the students, I did show the video to the students in my class, and they were all chomping at the bit to want to play the game. And, oh, yeah, please, figure out a way to make us do this, which is nice. They're wanting to learn. So I'm actually planning on introducing it again in my Calculus 1 classes as a review heading into the final and doing the same sort of thing and tying an assessment to that. And so some student comments, not only from my students, but then from some of these efficacy students that Tricem's been doing, both at Texas A&M and FSU, right? Was the other, yes, FSU was the other school. And so you can see the students, they like this. And in fact, Tricem's in development currently with 3 more games to basically cover all of Calculus 1. And I and a couple other mathematicians are consulting with them to make sure that not only does it teach calculus, but that the concepts are sort of seamlessly lined up across the games, and that it all makes sense in the game world. And we've actually been spending a lot of time on when you get to the application or word problems, both in max-min and also related rates. The biggest push has been helping students learn how to set up the problem. If students are like mine, most of them, once you give them the equation, they can take derivatives and so forth. It's learning how to formulate the problem. And so that's been trying to integrate that in a natural way into the game. And we don't know the time frame for that. That's all still in development, but that is down the road, future developments, ideas for this. So I'm going to hand it back over to Amber here for talk a little bit more about Tricem and how to follow up on all this stuff. But if you see me at a conference or if you connect with me on social media, I'll be happy to talk more about this or answer questions and so forth. So Amber, hand it back over to you.
Rob, thank you for that presentation. We had some great questions in the chat box, and we'll be getting to your questions shortly. Please, at this time, if you have any additional questions, enter them into the chat box. While you're doing that, I'll tell you a little bit about Tricem. Tricem is an educational gaming student studio formed in 2014 out of the Live Lab at Texas A&M University, with the aim to improve student outcomes at the college and high school level by using educational games initially developed by the Live Lab. Rigorous instructional design and research were used to transform educational experiences both in and out of the classroom. In addition, our game development team, which includes game designers, artists, programmers, and engineers, work closely with educational and subject matter experts to create these immersive experiences and achieve these specific student learning outcomes. We are very interested in your feedback on gaming in general, variant limits specifically, and the future of math and calculus games. As Rob mentioned, we already have 3 more games in the pipeline to cover all of the Calculus 1 curriculum. To give us your feedback, click on the link in the chat box or contact him at temealy@triceum.com. Again, we are dedicated to helping your students master these concepts and ultimately succeed in your course. If there's anything we can do to help you or your students, please feel free to reach out. Within 24 hours, you'll be receiving an email with a link to the recording for the webinar. Again, thank you for joining us today. Rob, let's get started with some questions. Our first question, and you briefly mentioned this in your talk, is have you seen an improvement on student grades using variant limits?
So the short answer is yes. Again, it's not a huge sample size. It wasn't terribly rigorously set up, just the nature of the class size at that point and other things. But yes, more importantly, I think, at least for my Calculus 1 students, was the enthusiasm about visiting limits again, even from the students who were kind of, this is boring. They were literally, some of them were popping out of their seats and, oh, wait, please let us play this game. Do they have it on Steam? Do they have it? But all this stuff related to it. Some of them were even asking, well, wait, what language do they program in it? How do they do this? And so it was really, the excitement was nice as opposed to the sit in the classroom sort of a thing. The other nice thing is that more or less about 6-ish hours of gameplay, most students can get completely through the game, maybe 8, depending on how fast they run through the game and stuff like this. So it's not a huge time burden. It's not hundreds of hours or so, but it's enough that they're immersing in the game, but it's not enough that it starts to feel like it's a drudgery or they're really slogging through the game. And so that was one of the nice things, is that you can do it. And then I see somebody's popping up about other plans to address other topics. Yes, 3 more games to eventually basically cover all of Calculus 1 up through integration and maybe even integration. We haven't quite figured out where that boundary is in terms of game size, time frame to play the game, and so forth. But that is how we go there.
So we have a question. Is the game structured like a video game where Zone 1 must be completely done before Zone 2, etc.? Or is it more like a traditional homework assignment where you can pick and choose puzzles?
So there is a way you can, well, it is like a video game that there's a walkthrough world and you walk to puzzle and so forth. Excuse me. But there is also an ability, at least on the instructor side, to sort of fly to particular puzzles and zones once you've completed them. Now there are some puzzles where you have to unlock all the features in that puzzle to pass it. You have to go do some other side puzzles, but it is structured that way. But there is a way that you can basically, if a student's just completely stumped on one puzzle, you can sort of hurdle them past that so that they're not just stuck in the game and floundering, and that you can decide, okay, yeah, here, let's get you past that real quick, and you just go on to the rest of the game. And I had to do that with a couple of my students. Either something about their computer wasn't working or something was going on, and we just basically teleported them past the game, that particular puzzle, and they went on and had a great time. So there's you don't have to worry about the student getting hung up at a particular place. It works.
Thank you, Rob. That brings up a really great point. Within the game itself, there's 2 roles. There's a student role and an instructor role. As a student, as Rob mentioned, you walk through the game from Zone 1 to 2 to 3 to 4. Each level builds on itself, and at the end of each level, we have what we call an assessment puzzle that is a more complex, complicated problem where they can't necessarily see what's happening in the environment and relate it back to the puzzle. But they've got to solve that assessment puzzle, which brings all of the concepts from that zone together in order to move on to the next zone. As students progress through the game, again, each zone builds on one another. So what you learn in zone 1 gets applied to zone 2. When you move into zone 3, you actually use principles from 1 and 2, not just 2, to move forward. And then zone 4, you'll use those similar principles from 1, 2, and 3 to complete the game. As an instructor, we provide you with a puzzle key that enables you to see images of each puzzle within the game. And students have the ability to click on an information button to grab what puzzle they're in, and they can send you an email and say, hey, I'm stuck at puzzle 1.1. You can use the key, look up what that puzzle is, and help that student past that specific concept or area. So again, there's 2 roles within the game. Our next question, and I think Rob talked about this, is the game short enough to be completed in a few weeks, like a calculus class normally spends on limits? Rob, do you want to talk about that?
So for a standard engineering calculus, or that's what we call it in blended engineering calculus, or the regular Cal 1 of Cal 1, 2, and 3 semesters, yeah, like I said, it takes about 8 hours of gameplay, give or take, depending on how immersed the student dives into it. And so it easily fits in, excuse me, in that time frame. Now, in our business or applied calculus, we're spending a week and a half in that. And then so that time frame and that type of student, maybe not. So that was one reason why I did it more as a review of the particular of the going into the final exam, because it's going to pop up again on the final exam. This was a more interesting way or entertaining way for them to come back around and revisit it. And then just in passing, so one of the things that we did when we designed the game and then designing the future games, we sat down with basically, okay, in the standard calculus class, when you cover these topics, what are the basic learning objectives you want, all with the nice Bloom's taxonomy verbiage and all that stuff about learn and analyze and remember and apply and so forth. And so there are ways that Trisim will send you all those different learning objectives for the game and the zones and so forth. So you can, if you need to do any sort of matching up, or in my case, I had to make sure that to write out for a documentation so that our crediting agency would say, oh, yes, these are matching up to these particular learning objectives. This is how you're assessing those, all that stuff. So yeah, there's all that's available there for that too.
Thank you, Rob. You pointed out a really great that we have all of the student learning objectives posted. We actually have them posted on our website, variant.tricm.com. And I can follow up with you, Ellen, specifically, since you asked the question. I can send you the PDF. If anyone else is interested in the PDF of the student learning objectives, I can also send that to you if you contact me at atm@tricm.com. Rob mentioned mapping it back to his textbook. We also have a textbook mapping document where we've mapped the most popular textbooks out there. So if you're interested, please contact myself or Tim, and we will send you that document. So we had a few more questions roll in. Is there a trial or demo besides the trailer that we can plan on how they would use it in class? So Larisha, we actually have 2 things. We have a walkthrough video that walks you as an instructor through all 4 zones. It's about 10 minutes, and I can send that to you as well. We can make that, it's available on Vimeo. In addition, we do have trials and demos for faculty. We will set up an account for you so that you can get into the game and you can play it. To get that demo or trial account, you would need to contact Tim Neely at teneely@tricm.com, and we'll be happy to get that set up with you as soon as you contact us. Okay, so we have a comment about, I don't think my students are playing video games or into video games that much. What can I do? Rob, do you want to talk about what your students saw?
So that's interesting because a lot of my students, once I showed the trailer in class, were actually kind of excited about, hey, I get the chance to learn calculus in a different way. So potentially you could even have the students, if you wanted to go through and critique the puzzles in the game, so to speak, if they're serious about it. So I'm speaking off the cuff here, but if you want to contact me, we can talk more about it in a conversational form. Right, so pull up a couple of 3, 4, or 5 of the puzzles, sort of an extension of what I did in my examples, and have the students say, okay, so to get this concept across, this is how they chose to do in the game. What do you think would have been better or more effective, sort of a thing? So in essence, you're asking the students to create their own questions, but you're not hammering in on the students. You're sort of using the game as a third party sort of thing you can all point at and critique, and nobody's feeling hit up by that or sort of beat down by that. And then this is, in some sense, right, as we go more game-based or more individualized instruction, either blended or online or flipped learning or whatever that format looks like, this is sort of, in some sense, the next step for engaging students. So you could even ask the students at that point, okay, hey, if this becomes your job as an engineer or as a scientist, how does this work? What would you want to see in a game then at that point? And so you could even, the first time I did this, I sort of gave my students an out. Okay, do you want to play the game or do you want to work through these particular quizzes? Because for some of my students, they were on financial aid, there was a cost concern. And so maybe that works too for your students. Just ask them, okay, hey, would you rather play the game for this point? And I think Amber put a comment about pricing in there. Or would you rather work through these particular things and then sort of let them decide? And for most of my students, when I threw out the price point, they're like, who cares? I'll pay that. I just want to play the game. So anyway, I hope that helps you, Amber.
Yeah, thanks, Rob. One of the things we've seen in our IRB research is most of our students, about 95, 96% of the students, are playing games for 4 or more hours. We have had comments from students that said, wow, I wasn't a gamer, but I got in the game and I really enjoyed it. I had a great time learning calculus principles and I was able to apply it back to my course. So you may be surprised at how much your students do game, but they may not be telling you that they're playing games. So send them the calculus game and have them play it. At this time, I think we have addressed all of the questions. If you have one last question, please go ahead and enter it into the chat box. We'll stay on for just a few more seconds. Again, thank you so much for taking the time today to join us for the Variant webinar. If you have any questions, again, please email myself at atm@triceum.com or Tim Neely at teneely@triceum.com, and we'll be glad to answer any questions you have or set you up with your instructor demo accounts. Thank you so much, Rob, for this great presentation, to the Triceum team for putting this on. Again, we hope you'll have a great afternoon. Thank you so much for joining us.